Okay, so we're talking about how to calculate acid and base pH and pOH. Do you remember like what pH and pOH mean, like what we use those for?
Um, pH, is that a scale for hydrogen? It's kind of like pH. It talks about how much
hmm
hydrogen's in something.
Yeah. It's
Okay.
talking about the concentration of hydrogen in a solution, and it also tells us like how acidic or how basic something is,
Oh,
right?
okay, okay. Mm-hmm.
So what we're going to do is kind of apply a little bit of a math to that concept, right? So it's not just about telling us whether it's acidic or basic. It's also what you said. It's like how much hydrogen concentration is in there.
Oh, okay. I love adding math to
Oh yeah, it's so much fun, right?
things.
So let's go ahead and get this down to start with, right? We know what pH tells how acidic or basic something is, right?
Mm-hmm. And the more hydrogen we have, the more acidic.
Right. The more hydrogen, the more acidic it is. So pH from 0 to 6 is an acid, right? We know that.
Mm-hmm.
And if it's from 8 to 14, it's a base, and then 7 is neutral, right?
Mm-hmm.
Now, what these bracket things are, that means concentration of hydrogen, right? So we want to remember that. This bracket thing right here equals hydrogen concentration.
So it's like the molarity.
Yes, it is
Oh,
molarity.
okay.
That's right, it's the same thing as molarity. And then the OH is concentration of OH minus, right?
Mm-hmm.
So in brackets means hydroxide concentration.
Oh.
So when you have a concentration of hydrogen that's greater than the concentration of hydroxide, you got an acid. But if the concentration of hydrogen is less than hydroxide, it's going to be a base. Okay, so now for the math part. We got how to calculate pH using the concentration of hydrogen. And what we're going to be using is this log button. You don't really need to know exactly what log is, but if you go into like calculus and all that later on, then you'll learn what it is. But right now, all you need to know is that the log button is on your calculator right there. Okay, so this is the one that we're going to be using. That's how we calculate pH using this log button. Okay, you think you remember where that button is?
I think so, right under the second.
Yes, right. And we're going to use the second button too, but not just yet.
Okay.
So here's the formulas right here. Okay, to calculate pH, you have the negative log of the hydrogen concentration, whatever that is.
Oh, so we're using the amount of hydrogen we have, and
Mhm.
then the calculator's going to do some math for us, and it's going to tell us what the power of that hydrogen is.
Yes, that's
The
right.
strength.
Yes, how
Awesome.
strong it is. And if it's really strong, then we know we got an acid.
Gotcha.
So let's use an example. Okay, so it wants to know what the pH of a solution is. What is the pH of a solution if the hydrogen concentration, that's what that is equal to 1 times 10 to the negative 6. That's actually a really small number.
Really small number, yeah.
Really small number. That's how many hydrogen protons are in that solution. So we got to look at this formula up here. Okay, that's the one we're going to be using. And here's how you type that in to your calculator. Okay, I want you to keep your eyes on that formula up there above the calculator. We want negative and then log of 1. And then we're going to do second E. That means times 10 to the, right, negative 6.
And one thing we want to be careful is not to put the subtraction sign. We want to use the
Right,
negative
yeah.
symbol.
You don't want to use the subtraction sign. You want to use the negative symbol that's like down here. Okay, that one right there. That's the one you want to use. That means negative. Doesn't mean minus. If you put in minus, then everything's going to get messed up.
Yeah.
Okay, so we used second E, right? The second, and then the negative X button, and that got us that E. And then we hit enter, and it's 6. Okay, so we got a pH of 6.
And since our acid is from about 0 to 6, so it's acidic.
That is acidic, that's right. Okay, well that was pretty simple, right?
Yeah.
Now let's go kind of the other way. We want to know what the OH concentration of a solution is with a pOH of 3.2. So we are going to use this, that formula right there. So we're kind of going the other way. To go from pOH to, to go from concentration to pOH, use the log, just like we did before, right? But now we're going backwards. So we are going to take
So we're kind of saying if it's this strong, we must have at least this many of those little ions in
if it's got a pOH, then we know, or this much, how much hydroxide concentration is there. So for this, we are going to need second log. Okay, so we're going to do second log. Oops, not that one. Just kidding. Did I say second log right there? There we go. Of negative 3.2. Okay, so you just hit second and then the log button. We need to remember that log button, right? And then type in your pOH, and it's got to be negative, and then close parentheses. All right, there we go. So that is a big, long number with a lot of zeros in front of it. We're going to convert it to scientific notation. Do you remember how to do that?
I think you go second and then the DRG button right next to it.
Yeah, we could do that. Second DRG. I'm going to change it to scientific. And then, ooh, there it is.
All right, so it's 6.31 times 10 to the negative 4?
Yep, that's right. And you got to include this times 10 down there.
Or we'd be off by a lot.
You'd be off by a lot, yeah. You can't forget about that. You don't forget about the times 10 down there. So 6.31 times 10 to the negative 4th. And it's got a pOH of 3.2, so I'm thinking it's probably a base, right?
Yeah, it's basic, yeah.
It is basic.
And that, since it's a concentration, would this be a molarity?
That is, yes. This is a concentration. That's right. Oops, move it up a little bit. Concentration. And that is the same thing as molarity. That's right.
All right.
This is the concentration of hydroxide in the solution.
And we could do this, for either one using these equations up here.
Yes, we could go, we can go either way.
We could go both ways, back and forth.
Which we're definitely going to do in the guided practice here in a little bit, yeah.
Now what does this mean right here? It says the pH plus pOH equals 14.
Yes, so if you have pH and pOH, it's got to add up to 14. So if you want to know the pH of something that has a pOH of 3.2, excuse me, pH plus pOH equals 14, right?
Mm-hmm.
So we could just do 14 minus 3.2, and that would tell us what our pH is.
It's like 10.8?
Mm-hmm.
Oh, I see. So if we know a pH, we automatically know our pOH.
Right, and this is the base right here.
Oh. So
Excuse me.
So if we know our pH or our pOH, we actually have two pieces of information.
Yeah, that's right.
Oh, that's
and
cool.
You can find out if it's an acid, you can find out if it's a base. We're more familiar with pH, but pOH is a thing too.
All right. And if you have any questions, ask a teacher.